All right, so in example 1, we are going to use the power rule a bunch of times together with the constant rule to just see the answers to these problems. So in example number 1, it says differentiate the following. So that word differentiate just means find the derivative, right? Now, since they're calling the problem y every time, that literally means that they want dy over dx. That's what they're looking for. So sometimes you'll see differentiate the following. Sometimes you'll hear the words find the derivative. Sometimes you will see just dy over dx equal to what? That all means they want the derivative. Okay, so for the first problem, I'm looking for the derivative with respect to x of the letter y. So in other terms, I want the derivative with respect to x of the quantity x to the power of 15. And as you can see in this problem, the problem has a letter raised to a power that's 15. So all I have to do is bring the 15 to the front and then take away 1 from the 15. So 15 minus 1, and the answer turns out to be 15 x to the power of 14. That's what we call the dy over dx. That's the derivative of the quantity that was written down. So if we try it again a few more times, dy over dx of the second one, the second problem has x to the negative 7. So it says d dx of x to the negative 7. So notice how I'm transitioning the notation. First off, it was dy over dx, meaning I want the derivative of y with respect to x. Next, I write d dx, which means I'm looking for the derivative with respect to x, and then I write what y is supposed to represent. Remember, y represents x to the negative 7, so the letter y gets replaced with x to the power of negative 7. Now, according to the rule, you bring the negative 7 down and you write down x to the negative 7 minus 1. That's what we call the power rule. And notice at that moment, I don't write d dx anymore. I just did the derivative. I just applied the operation that says bring the power down, subtract 1. So no need to write down dy dx at that point in time. And all I have to do at this point is write down some simplifications. So like for example, negative 7, negative 1 is negative 8. So negative 7 x to the power of negative 8 is the derivative of the original y. Just like earlier, the derivative of x to the power 15 was 15x to the power of 14. So both of these used the power rule. The power rule says bring the power down, then subtract 1. Now the next one says dy over dx, and the y this time is just simply pi to the power of 2. Now I just want to remind you that pi is a number. It's 3.14. It's not a letter raised to a power. It's a number squared. And the rule is anytime you have a number, doesn't matter what kind of number it is, doesn't matter what power it is, the rule says your answer is going to be 0. This is the constant rule. And the constant rule basically says, regardless of which number is in your problem, the derivative of a number is always 0. So that's a different rule than the first two that we did. Now the next one is interesting, dy over dx. This one is a common one, so you probably want to memorize the result of this one because it shows up so often. Again, the y is supposed to be equal to x. So I'm looking for the derivative with respect to x of the letter x. Now, if you think about it really, the x that we've written over here inside the parentheses has the exponent 1. And according to the rule, we bring the 1 down, then we write the base, and then we write the old power, and then we subtract 1 from that. That's what the rule says. That's what we did in parts 1 and parts 2 of this problem. Bring the power down, then subtract 1 from the exponent. Now once we do that, we end up with 1 x to the power of 0. And we need to recall that anything to the power of 0 is equal to 1. And so 1 times the 1 is going to be at the end equal to 1. So again, I used the power rule here, but it was a little bit weird because of the exponent being a 1. So instead of doing this work every single time, every time you see this x, it shows up very often in math, just memorize that the derivative of x is equal to 1, and it will save you plenty of time. But if you don't want to memorize it, you would have to do all these steps every single time. Now the next couple problems are going to be a little bit uglier because in these problems we have radicals. So the first one says we want the derivative with respect to x of the square root of x. Now it's bad to have radicals, so we need to switch the notation to powers, and hopefully you remember the formula. And the formula basically says that square root of x is the same thing as x to the 1/2. Let me explain. Remember that the square root of a to the power of m with an n on the outside is basically the same thing as a to the m over n. And when I write square root of x, there are a couple of things implied. First of all, the 1 is implied and the 2 is implied. So if I use my rule for radicals, I can rewrite this problem as x with the 1 that was on the inside on the numerator and the 2 that was on the outside on the denominator. So square root of x is the same thing as x to the 1/2. This is just one of those exponent rules that we reviewed at the beginning of the semester. So now that we have x to the 1/2, we can use the power rule, which says bring the power down to the front, then take away 1 from that exponent. So again, all we do is grab the power and slide it to the front, and then we take away 1 from it. So 1/2 was already there, and then we just take away 1 from it. And so we end up with 1/2 x to the power of negative 1/2. Now again, what does it mean to have a negative exponent? What do we mean when we write a to the negative m? From the review again, from the beginning of the semester, this is the same thing as 1 over a to the power of positive m. So it means that it wants to be on the denominator. So the x wants to be on the denominator. So it wants to be 1/2 x to the power of 1/2, just like that. And now we can rewrite it if we want as a radical with 1 over 2 square root of x. So it took a lot of time to get there. And as a matter of fact, any of these answers at the end is correct. You can leave it with a negative exponent, you can leave it with a positive exponent on the denominator, or you can leave it back with radicals. It does not matter. Any of those choices is perfectly acceptable.